Okay, we're going to take a look here at what is called a direct variation. And what we can see here, these are just like setting up ratios that are going to be kind of equal to each other. Okay, we call them proportional or direct relationships. Um, so what we're looking at here are kind of like points. So if we know when y is 15, then x is 5. All right, what we're going to do is I'm going to set it up with the y on the top and the x on the bottom. And what we're going to say, well, if y is equal to 15 when x is 5, then I'm going to set up the other side and say, well, what is y when x is 9? So what is y when x is equal to 9? So what you can see here is we have a proportion that is equal to each other, and we want to make sure that all the y's are on the top and all the x's are on the bottom. And then we can either cross multiply and solve, or what's more efficient now, since you're in algebra 2 here, I've got y divided by 9. If I multiply by 9 and multiply by 9 on both sides, okay, what you're going to get, the 9s are going to go away, and then you're going to be left with y, and then you're going to type that into your calculator. 9 times 15 divided by 5 will give you an answer of 27. Okay? So try to work ahead of me here, but it's the same idea, right? When we have y's on the top and the x's are on the bottom, so just make sure that all that is lined up correctly. So let's take a look at this. Y equals negative 6 when x is 4. So y is negative 6 when x is equal to 4. What is y when x is equal to negative 10? So notice how I have all the x's on the bottom, all the y's on the top. And now to solve here, it's the same idea. I simply multiply by negative 10, multiply by negative 10 on both sides. And why do I do that? Well, cross off, cross off. I've got my y just by itself. I'm going to multiply these, negative 10 times negative 6 divided by 4. I'm going to get positive 15. So use your calculator for those operations if you need to, especially to double check. And then the third example, same idea here, right? When y is equal to 12, x is equal to 16. So I'm going to put the 12 on the top, 16 on the bottom. I want to know, well, what is y equal? What is y equal when x is 24? Okay, so same idea. How would I solve this? Just multiply by 24 on both sides. Multiply by 24 on both sides. That's going to cross off. So y is completely isolated. And use your calculator for this, but you're going to turn into the y value is going to be equal to 18. Okay? Now, some of this is really related to distance and speed when you're traveling at a constant rate. We're going to talk about that quite a lot in this unit. But you can see a person can travel varies directly. That's a key. That means we have proportions with the time that they have been traveling if going at a constant speed. So Phoenix traveled 78 miles in 1.5 hours. So what we're going to do is we're going to put the miles on the top and the hours on the bottom. And I kind of recommend doing this when you're first starting to work on this, right? So I've got 78 miles in 1.5 hours. So I've got 78 miles on the top, and I've got 1.5 hours on the bottom. And while traveling at a constant speed, how far will he go when he travels in 2 hours at the same speed? Okay, so now I've got 2 hours on the bottom, and then I've got m, or the distance, or whatever variable you want to use on the top. Okay, so now if I go ahead and multiply by 2 on both sides, multiply by 2 on both sides, you're going to come up with an answer of 104 miles, because the 2's are going to cancel out, and then use your calculator to simplify that operation. Okay. Next one works proportions work very consistently with pay. All right, if you're paid, you're usually paid per hour in many jobs and many start-off jobs. Okay, so we're going to go ahead and take a look at this, and then we're going to find out what we have related to each other. Okay, so what we have here is hours and then money. Okay, so I'll put the hours on the top and then the money on the bottom, and then I'll just close that off just to make sure that I'm consistent here. So if I go ahead and identify, well, 35 hours, Jenna made that. So I'm going to say 35 hours. She made 274.75. How many hours would she need to work in order to earn $337.55, right? So again, you're going to say, well, this is what I need to know, right? Is 337 and 55. I'm looking for how many hours it would take. Okay, so again, you could cross multiply here. Again, we're in algebra 2, so let's just be a little bit more efficient. 337.55 on both sides, because that's going to cancel out. That's going to cancel out, and we're left with hours. If I multiply by 337.55 on both sides, multiply that in, you're going to get 43 hours. Okay. One more procedural thing here is, since we've been multiplying by the denominator, on our previous examples here, what I wanted to show you is what we actually mean when we say cross multiply here is if I got a fraction equal to a fraction, if I cross multiply, notice that there is an equal sign. It's a big element that students seem to mistake, or big times that students make mistakes here. And what we're going to do here is, if I multiply 8 times x plus 9 is one direction, and then 5 times x plus 3 in the other direction. So now you're going to see here that we are going to have a linear equation to solve. All right, so I'm going to distribute. So I've got 8x plus 72 equals 5x plus 15. Make sure we're getting both of those values in there. All right, and then I'm going to subtract 5x and then subtract 5x. So I'm going to get 3x plus 72 is equal to 15. Then I'm going to subtract 72 and then subtract 72 and then get a value of 15 minus 72. Use your calculator if you need to. I'm going to get 3x is equal to negative 57. Divide by 3. And then I'll get x is equal to a value of negative 19. So that's how you want to set up those linear proportions by cross multiplying and solving. Okay, so our last and final step is, how does this relate to linear functions, right? Linear functions are just graphed as lines. So you can see right here, we have what's called a constant of the variation, or what we can see here is kind of like what you would recognize as the slope here, the slope of a function. So if we know that 6, 4 exists, you can see, and there is the point right there. Okay, find the y values given each of the following x values. So if I wanted to do that, I would say, well, I know that 4 over 6 is the y over the x. So what am I looking for here? If I've got a y value over the x value is 3. So right now, you just multiply by 3, and what you're going to get is a value of 2 for the y value. Okay, so now if I've got an x value of 1, 2, 3, a y value of 1, 2, I'm going to put that point right on there. And then I'm going to say the same thing. Well, what happens when x is negative 6 all the way over here, right? Okay, what is our output? So what I can do, well, if I know 4 over 6, the y over the x, get used to writing the y on top. If I know that that works, I'm going to put negative 6 in the bottom. I want to say, well, what's the y value? What's the output? And again, one-step solving, multiply by negative 6, multiply by negative 6 on both sides, and I'm going to get a y value of negative 4. So there you go. I've got a y value down here, 1, 2, 3, negative 4. And you can see right now, what do I have here is a linear function, okay? So what we're looking at here is, what is the constant of the variation here, constant of variation here. And what we can do here is, that really just means the slope. So what is the rise over the run? It's the constant of the variation, Okay, it represents the slope. All right, so if I can check this slope here, I'm going to rise 2, run 3, rise 2, run 3, rise 2, run 3, rise 2, run 3. So rise 2, run 3, okay, represents the constant of the variation, which means we can write this, y equals 2/3 of x. Okay, so what is the equation of the line? It's just exactly that, y equals 2/3 x, and there's no y-intercept, or the y-intercept is 0, so you could write plus 0 if you want. So what makes this function linear is a constant rate of change. So important, constant rate of change. That's what makes lines into lines. It's the most basic fundamental unit of algebra. All right, hope this helps. Have a positive day.